In this example, I need to solve the right triangle shown below. I also need to round the answers to the nearest tenth. Here is my right triangle. And what are the methods that we can use to solve for parts of a right triangle? Well, here's a list of the tools to solve parts of a right triangle. The Pythagorean theorem. You can use it if you're given two sides and you use it to find a third side. The sum of the angles of a triangle is 180. That's if you're given two angles, you use it to find the third angle. And trigonometric functions you can use to find either a side or an angle. Now, looking at our diagram here, what information are we given in this triangle? We know this side here. We know angle B is 61.3 degrees, but don't forget we also know the value of angle C. This symbol here means angle C is a right angle and its measure is 90 degrees. So I'm given two angles, so I can use the sum of the measures of the angles is 180 degrees to find our third angle, angle A. So I know the measure of angle A plus angle B plus angle C, they have to add up to 180 degrees. I'm trying to find the measure of angle A. I know the measure of angle B is 61.3 degrees. So A plus 61.3 degrees plus the measure of angle C is 90 degrees equals 180 degrees. Now, adding up like terms on the left-hand side, I get A plus 151.3 degrees equals 180 degrees. Solving for A, I'm going to subtract 151.3 degrees from both sides of the equation. And so I get the measure of angle A is 180 minus 151.3 degrees, which is 28.7 degrees. So I've found the third angle in this triangle. Next, I need to find the lengths of these two sides of the triangle. But before I do that, I'm going to label my sides. Remember, the side opposite angle C is side C. So little c equals 150.5. The side opposite angle A is side A. And the side opposite angle B is side B. So I need to find side A and B. Now notice I cannot use the Pythagorean theorem because I need to know two sides. I only know one. So I'm going to have to set up trigonometric functions. And to do that, I'm going to use the mnemonic SOHCAHTOA. But before that, let's analyze the diagram a little bit more. I know angle C is my right angle. I'm given angle B. I'm given side C. It doesn't matter whether I find side B or side A next. I'm going to go for finding side B next. And what is the relationship of side B and side C to angle B? Well, side B is the side that is opposite my angle B. C is the side opposite the right angle, so it is the hypotenuse. And now I need to set up a trig function involving opposite and hypotenuse. As you can see, that comes from here. So I know the sine of angle B, which is 61.3 degrees, is opposite over hypotenuse. So the sine of 61.3 degrees, the opposite side is B. divided by the hypotenuse, which is 150.5. And now to solve this for b, I just need to multiply both sides of this equation by 150.5. These 250.5s reduce, which just leaves me with b. So b equals 150.5 times the sine of 61.3 degrees. So now I need to get my calculator. Here is my calculator. It is a TI 84 Plus. I need to make sure it's in degree mode. So hit mode. Notice degrees highlighted. So all I have to do is quit, which is second mode. Now I'm back to my home screen. I just need to type this expression in there. So 150.5 times the sine of 61.3, close parentheses, hit enter. So here's my answer. I need to round it to the nearest tenth. That's the position of the 0. The 1 is not going to round that up. So my answer is 132.0. So that is the value for side B. Now I need to find the last part of the triangle, and that is side A. Since we were given side C, I found side B. I could use the Pythagorean theorem to find side A, since I now know two sides. But if I'd have made a mistake finding side B, then side A would also be incorrect. I prefer to use given information, which is the value of angle B and the length of side C. Can I set up a trig function using these three pieces of information? Well, side A is the side that is adjacent to angle B. And can I set up a trig function involving adjacent and hypotenuse? Yes, it comes from here. So I know the cosine of 61.3 degrees is adjacent, excuse the bad handwriting, over hypotenuse. So the cosine of 61.3 degrees equals the adjacent side A over the hypotenuse, which is 150.5. Multiplying both sides of this equation by the hypotenuse. Now these two reduce, and I get left with A equals 150.5 times the cosine of 61.3 degrees. Now putting this in the calculator, 150.5 times the cosine of 61.3, close parentheses, hit enter. Here's my answer, round to the nearest tenth. That's the position of the 2. The 7's going to round it up. So side A is 72.3. So now I've solved this right triangle, but one thing you can do at the very end to check your work is you can use the Pythagorean theorem to see if you get a true statement. So I'm going to take a squared plus b squared to see if it equals c squared. Well, a is 72.3, so that's 72.3 squared, plus b squared is 132.0 squared. Here's that total, and I need to see, does it equal 150.5 squared? Are these two numbers the same? Yes, they're approximately the same. Why are they a little different? It's because I rounded both of these answers, so they're only going to be approximately equal. But that is a great indication that you have this problem correct.